Hello, this is Dr. Oz. In this video, I would like to show you how to conduct linear programming prescriptive analytics models using Excel Solver. Go to Blackboard, please, and under linear programming, you should be able to see this tree network minimum cost flow data file. Please download that file to be able to build this model. Click on this little icon to download it and open your file. So once you open it, please enable it to be able to build your model. So this is the given information for this model. We have 9 different arcs connecting these origin nodes with its destination nodes, and these are the costs associated with each shipment from this location I to this location J. And each arc that connecting these origin and destination nodes have specific maximum shipment capacity that we can go beyond that. And from Syracuse location, we can maximum ship out 15 units per day. And Albany, we have to satisfy 5 units of demand, and Buffalo 6 units of demand, and New York City 4 units of demand. And also another thing that's important in this model is that Rochester is a hub, so that means that in and out from Rochester location should be the same, and same thing for the Scranton location. Scranton is a hub as well. Okay, so this is the given information. This is how I like to structure my Excel files in general. Put the given information on the left hand side and build my model on the right hand side. So let's build a model here. I'll click on column F, Control B to bold it, and I like to use different color, let's say teal color and red. The first step in optimization models is to define the objective function. Objective function is either maximize good things or minimize bad things. In this case, we are trying to minimize bad things, which is a cost, because everything here that's given in terms of cost. Minimize the cost. I'm going to click on it, Control B to bold it. And I like to use green cell to represent my objective. Second step is to determine the decision variables. In this case, I have 9 different arcs. So these are my decision variables. I will copy them. And number of shipments on each of these arcs will be my decision variables. Go between two letters, double click when you see the symbol to adjust the width, Control B to bold it. So I like to use yellow cells for my decision variables. Finally, third step is to determine rules and regulations. We call them constraints in modeling. And constraints have 3 components in general: left-hand side values, which are in general uh, calculated, versus right-hand side values, which are in general given to you. So I would like to bold these as well. Control B, top left corner to select entire worksheet. Between two letters, when you see the symbol, double click to adjust the width. So first set of constraints are the arc capacity constraints. I like to use red color here, so I'm just gonna choose a red color. So capacity arc 1, and I have 9 arcs in this model, so I will just create those. And right hand side the values, which are capacities given right here. Click on that cell, right down corner, black cross, drag it down. And the relationships should be either like less than or equal to, greater than or equal to integer, binary, and so on. So in this case, these are the maximum capacity, so it should be less than or equal to. And I cannot exceed these shipments amounts. Now I need to look at carefully each of these shipments. So arc 1 shipment will be coming from here, and I will drag it down. So for example, if I put here one, let's say 1 shipment and 3 shipments, there is no violation. As you can see here, 1 shipment is less than or equal to 6 and 3 is less than or equal to 5. Let's go to second constraint, which is maximum from Syracuse constraint. And the right-hand side value is given as 15 units per day. Again, maximum I can ship that much from Syracuse, so less than or equal to. Now I need to carefully look at all the shipments from Syracuse, which will be sum of 1, 2, 3. And if you press Control, you can click over here as well for these 4 locations. And currently 4 shipments, which is less than or equal to 15. Again, I chose these numbers randomly. Okay. In top left corner, double click. Okay. Control S to save. So we dealt with this one as well. So next one is the we have a set of constraints that includes demands. These 3 constraints: demand Albany, and drag it, Buffalo and New York City, and demand values are given 5, 6, and 4. Again, we must satisfy demands in this example, so that's why it's the equality constraint. Drag it down. And now we should again carefully look at all the shipments to Albany. So I see here plus, I see here plus, I see it here. Same thing for Buffalo. All the shipments to Buffalo, I see it here plus, I see it here. That's it. And let's do the same thing for New York City. I see New York City over here plus and over here. Okay. And these are constraints, and I like to use red color for my constraints. So now I have 2 more constraints, which are hub constraints, which means the in and out from Rochester and Scranton should be equal. What I'm gonna do is, I'll just highlight here. Um, and ref in equals to outbound traffic, Control C, Control V, and these constraints, let's label them. Okay, so everything goes into Rochester right here, plus, there's no plus, that's the only Rochester I see in 2 column. And then Scranton, everything goes into Scranton. I only see it here. I just want to make sure I'm not missing anything. Perfect. And then these are equality constraints as well. And everything out of Rochester right here, plus right here, or I could do some as well. It doesn't matter. And right here, I see 3 times Rochester. And then same thing for Scranton. I see Scranton here and here. Okay. All right, so now what I need to do is put this in the model to solve it. But before doing that, sorry, I forgot to calculate the objective function, which is minimize cost. And cost can be calculated by the parameters, which are cost in this case, times their corresponding shipments variables right here. So I use some, not some product function. Perfect. So now, like for example, if I ship 1 product from Albany, that will cost from Syracuse to Albany, that will cost us $400, and Syracuse to Buffalo 350 times 3, which is 1050 plus 400 will be 1450. This is just an example. But again, I've just put these numbers as an example. You don't have to have any values here. So now click on the green cell, and under data tab, you should be able to see solver if you used solver before. If you haven't, you go to file, options, add-ins, analysis toolpack, click on go, check the solver add-in, click OK. It will take a few seconds, and then you should be able to see solver under data tab. Click on that, and the objective function is the green cell. Enter. We are trying to minimize it. Variables, these yellow cells, highlight them, enter, and constraints. And I want these values, as long as they have the same relationships, you can add them in one step. It must be less than or equal to these right-hand side values, enter, add, and also these left-hand side values, since they have the same relationship, must be equal to these right-hand side values. And click OK. And this will make sure that the shipments cannot, yellow cells cannot be negative. And we use linear programming since the objective function, decision variables, and all the constraints are linear functions. Click on solve and click OK. So the best solution for this problem is to send 5 units from 5 products from Syracuse to Albany, 5 products from Syracuse to Buffalo, 1 product from Syracuse to Rochester, 1 product to Rochester to Buffalo, 4 products to Syracuse to Scranton, and 4 products from Scranton to New York City. That will minimize the cost, which is $6,500. And as you can see, all these values are less than or equal to their corresponding right-hand side values, and all these values are equal to their corresponding right-hand side values. That's it for this video. Until next video, enjoy business analytics.